Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about our study guide. We got a test coming up for this upcoming module, and I have a study guide that we're going to go over in preparation for the test. These questions are similar to the questions that we will see on the test, so I just want to take a few minutes to go over it in preparation of being in the best position to run this test. So let's go ahead and get started. Let's look at this first question here. It says, what graph represents the equation 4x plus 2y equals 8? And so you can do this a number of ways. We've been familiar with using our Desmos technology at this point. If we put this equation in our Desmos calculator, this is what the graph looks like. Notice you have your x-intercept at 2, 0 and your y-intercept at 0, 4. You're trying to see which graph. First of all, the slope is negative. So since I have a negative slope, that's going to eliminate graphs A and D already. Now I just got to compare between my two graphs B and C, and I got to see which one has a y-intercept of 4 and an x-intercept of 2. This right here has a y-intercept that's negative, and my x-intercept is negative, so it's not going to be C, so it's going to be B. Graph B would be the answer choice there. All right, let's take a look at number 2. The equation of the line describes a graph on a coordinate plane, which is in point slope form. It says which graph represents the line. You can actually type this equation in point slope form as is into your Desmos, and it will still graph it for you. If you type this equation in Desmos, this is what our graph looks like. Notice we have our x-intercept. It's not a whole number. It's slightly above 4. All right, and then your y-intercept is slightly below negative, or slightly above -6. It's a positive slope, so it's going to eliminate graph C. All right, and so you want to see which one this could work. All right, if I look, this one right here, look at your x and your y-intercept. They're almost at your origin, so it's not going to be that. Look at your x and y-intercept here. Your x-intercept is negative, your y-intercept is positive. It's not going to be that. It would have to be graph B, all right, because you do have a positive x-intercept and negative y-intercept. All right, let's look at number 3. Which equation represents the line of a slope 3/4 and passes through the point of -2, 5? Notice your answer choices. Your answer choices are in slope-intercept form. So if it was in point-slope form, you could have rolled it in that, but we want to write this in slope-intercept form. Remember, our slope-intercept form is y equals mx plus b, all right, where m represents your slope, b represents your y-intercept, x represents the x-coordinate of your ordered pair, y represents the y-coordinate of your ordered pair. So what we need to do is we're given a slope, we're given our x value and our y value, but we need to find the y-intercept so we can write it in the slope-intercept form. All right, so what we need to do is substitute 3/4 for m, -2 for x, and 5 for y, and we want to solve for our y-intercept. So we'll have 5 equals 3/4 times -2 plus b. 3/4 times -2, that's going to give you -6/4, which can be simplified to -3/2. All right, so we got 5 equals -3/2 plus b. Now we got to get b by itself, so we got to bring 3/2 over to the other side, and so we're going to add 3/2. Now, -3/2 is the same thing as saying 1.5. So if you got it as a 1.5, that's the same thing. So we add 1.5 because it's the inverse operation. 5 plus 1.5 is 6.5. So you'll have either 13/2 or 6.5 as your y-intercept. So if my slope is 3/4 and my y-intercept is 6.5, then I have y equals 3/4 x plus 6.5. That's going to be A. All right, let's look at number 4. It says a group of students recorded the number of hours they studied and their corresponding test scores. The data is shown below. Which equation best represents this relationship? What you want to do here, first of all, this is in slope-intercept form. The only difference is your x and your y are different variables. So instead of x, I got h. Instead of y, I got s. And so you want to kind of look at like this trend of data right here. Okay. I could plug these in into your Desmos. You could do that, and then you could add your regression. All right, and look at your equation here. Look at your slope. Look at your y-intercept, right? Look at my y-intercept. My y-intercept is close to 50. All right. So I want to choose which one of these to have a y-intercept close to 50, and then it has a slope close to 5. All right. And that's going to be B. All right. But another way to do that, if you didn't type this in Desmos, look at your graph right here. All right. And if you look at your data points, this point right here, if you're trending, right, based on the trend of this data, this point, right, is probably going to be around 50, close to 50. So our 50 would be a good representation of an estimation as far as another point, according to your trend of your cluster of scatter plots here. So B will be the answer. Let's look at number 5. It says which line models the data in the scatter plot. So we're looking at which one has a the best representation of your line of best fit. If you look at graph A, this is below most of all of your points. All right, most of all of your points. So this won't be a good representation of the line of best fit. Look at graph B. Now graph B looks like it's pretty much through most of all of your data here. Okay. So this look like it could be a good representation. C is also relatively close, but if you look closely, look at these points here. Look at graph B versus graph C. See, if I had to go based on my trend, could have another point there. Your line of best fit want to start right close to your point here. This is a little bit below, all right? So it's not quite in the middle as graph B is. Graph B would be a better one. Graph C could work, but graph B is a better line of best fit. If you look at D, all right, that's line of best fit's in the wrong direction. That's a negative line where your slope has a positive correlation. So graph B would be the answer choice because graph B is the best representation of the line of best fit. Okay, let's look at number 6. These are ordered pairs. It says what of these best represent on a correlation coefficient. So we can type this in our Desmos, add our table, put in our ordered pairs, and then create our regression. When we do that, we want to look at our correlation coefficient, which represents by the lowercase r. Okay, excuse the bell. And if you look at your lowercase r, we can say that our correlation coefficient is approximately 0.99. That's a very strong positive correlation. Okay. Let's look at number 7. Number 7 says the scatter plot shows the number of questions the student answered incorrectly on a test compared to the number of hours each student studied. It says based on a linear model, which is the best estimate. So we're not getting an exact number, we're giving an estimate that a student will answer incorrectly if the next test of the student studied for 2 hours. So what you want to do, look at your hours studied, look at 2. And you want to go all the way to where you see, actually, I want to go here. So I put the line in the wrong spot. You actually want to go all the way up here, closest to your line of best fit, which is here. So if I went to my line of best fit, is right, we'll say about 15, all right, or 15.5 or something like that. It's relatively close to 16. But it's closer to 14 than it is to 18. All right. So we will say that B would be the answer for that particular one. All right, because we'll approximate it. All right. Let's take a look at number 8. This table shows that the relationship between the high temperature and the amount of money a vendor made selling ice cream, which equation represents the model. So we want to go ahead and type in go ahead and type this in our Desmos calculator, add our table, create a regression. And if we do that, look at our equation. Y equals 6x minus 240. And that's going to be answer choice D. Let's look at number 9. Scatter plot shows the association between the amount of time spent exercising and the number of calories burned. The regression line is shown, which models this data. It says which statement describes the y-intercept in context of the situation. So we want to see what the y-intercept could be. And so if we look at the y-intercept here, we're saying here, and it's kind of hard to see. If we type each one of these into our Desmos, you can kind of get a better picture what your equation could be. But look, it's not exactly at zero. It's a little bit above zero, and it's in increments of 100. All right. And so if it's in increments of 100, it's almost halfway through. So we can approximate that this could be about 50. All right. So it crosses the y-axis at about 50. So think about that. If my y-intercept is 50, think about what that means in the context of the situation. We're looking at how much time we spend exercising versus the amount of calories we burn. So our y-axis is when x is 0, y is 50. So what does that tell us is that if we don't exercise, right, we spend no time exercising, then we already burned 50 calories. So your answer would be C. And then look at number 10. All right. The scatter plot look at the relationship between the hours of sleep and the productivity score. This is our regression line here. And what we're trying to do is we're trying to find our slope, and it's saying what does the slope mean. So we find our slope here, and we could try to choose 2 points and do our rise or our run. It's kind of hard to do here, but we can make a good guess. We could say here, it count by 5, right? So 5, 10, 15, 20, 25 over 1, 2, 3, 4. 25 divided by 4. That's a little bit more than 6. All right, 6 point something. So we can approximate that our slope is 6. All right. And so what it's telling us is, if we're looking at our answer choice, that a person's productivity score increases by 6 points for every additional hours of sleep. Right, because as the hours of sleep increase, the productivity score increase. All right, let's take a look at number 11. Which scatter plot shows a strong positive correlation? So look at what positive correlation means. As x increases, y increases. All right, so both of these are positive. This doesn't look like an association because it's not moving up or down. This is a negative association. We have to look between A and B. Since A, the points are closer together for point A than it is point B, then A would be the strong positive. Let's look at number 12. We're trying to see the correlation coefficient and what does it represent. And so let's take a look at this here. And so we put this in our Desmos and we create our regression. All right. We see our equation right here. Well, not our equation. We're looking at our lowercase r, which is this right here. Is 0.99. So we can say that 0.99 is our correlation coefficient, is strong positive. So what that tells us is as the number of ads increase, the product sales increase, you're looking at A. Okay. Let's look at number 13. A nutritionist observes the number of sugary drinks consumed per week increases. The average body weight also tends to increase. No other factors. So that means nothing else can contribute to this. So since there's no other factors, what we can say is there is a correlation because as x increases, y increases, and since there's no other external factors, then we can imply that this is causation. So our answer would be that this is both correlation and causation because there's no other external factors. All right, let's look at number 14. It says researchers observed that the number of sunglasses sold tends to increase during the months where the number of beach visits are high. What other statements are most likely true? Now, it doesn't say that there are no other factors involved, all right? We do know that there's correlation. As the number of beaches population increase, the sunglasses sold increase. So there is correlation, but however, we cannot say that there's causation because there could be other factors. So your answer would be C. And then lastly, we want to look at the correlation coefficient here. So we're going to type this in our Desmos, look at our R. We got 0.99. 0.99 is our correlation coefficient, and it tells us that we have a strong positive correlation. As the training hours increase, the productivity score increases. So these questions here are questions similar to what we'll see on our upcoming assessment. Hopefully this will help in preparation for that test. And so, yeah, there we have it. And that concludes our study guide.